Really quickly about me, I don't have that impressive a resume, but I am the traffic lead for WSP out of the Tempe, Arizona office. Got 9 years experience in Arizona. Really worn 2 hats in that experience. The first one being traffic operations and modeling, and then the second one being traffic signal design and ITS infrastructure integration and design. With that first hat, microsimulation, I've done quite a few different softwares: Synchro, Vism, Rodel, HCS, and on the safety front, IHSDM. And another thing is I've done quite a bit of experience out in the field working with traffic signals. Probably the largest project working in that avenue was the Valley Metro light rail extensions in Mesa for Central Mesa and Gilbert Road, which I was in charge of analyzing and testing all the hardware for the traffic signals and ITS systems, as well as developing the controller software and logic statements for TSP. The next bullet is just kind of a blurb. I'm always looking for new ways to calibrate our traffic models, because it is really important that we use accurate and real life data, to calibrate our models and be able to make decisions for where should we put the financial resources into infrastructure projects. They'll give us the most bang for our buck. And I'm going to keep this presentation really high level. So any of the traffic modelers out there, if you'd like to talk with me in more detail about the modeling, please feel free to reach out at steven.doubek@wsp.com. And to jump back a little bit on who WSP is, we're one of the oldest continually operating engineering firms in the world. And the US division was formerly Parsons Brinkerhoff, which I think a lot of you, that name may be familiar. We were founded in 1885 and started off looking and designing the subway system in New York. And since then, we've grown to about 10,000 people in the US across 100 offices. Going more into Arizona, we have 2 offices now. We first started in 1981, and now we have a Tempe office and a Tucson office. Quite a few different business lines. By our biggest sector is transportation and infrastructure, where we're planning, designing, and offering construction services for roadway improvements, light rail, heavy rail, aviation, basically any mode of transportation. So we also do have a buildings arm that works a lot with hospitals and integration for facilities there. And I just kind of want to have these canned questions on what I think of big data or data in general and how I use it as a traffic engineer. How often do we collect data? It's every single project. So we can answer the right questions to be able to come up with the right recommendations to carry on through the design process. And what kind of data do we collect? I always like to make the joke that if it moves, we count it. So vehicle, peds, bikes, I've counted animals, I've counted trains. All of our designs need to encompass multimodal transportation. So, and then for calibration, a lot of times it's speed data, travel time, and in the case study that we're about to jump into with the urban freeway, origin destination becomes crucial. And then how do you just decide what data collection tool to use? It's based upon every single project. What are the answers that we need to get? What are the questions we need answers for? What are the time constraints? And what are the financial restraints? And the last question, what have I seen working with big data? And I've done about 5 projects recently with different platforms, including StreetLight. And the big thing that comes to mind is how much data that is out there. I know back in college, I worked to deploy Bluetooth sensors to a small area around the university. And the data we got back just from that small deployment, we were freezing Excel, running out of rows. And then to think about it as being the whole US, the whole world, all this data is incredible. So ease of use of the platform you're using is critical, so they can take all this data and bring it to analysis that you can use to make decisions. And the next part about big data is how reliable is the data? What is the validation process? What's the calibration that's documented for the different platforms? And I think that's another crucial part when you're looking for a partner with big data. And the last part is probably the most crucial, the support of that data provider. And what I'm talking about is when you're in the 10th hour of a traffic analysis and you need to complete it and get your recommendations out, a lot of times you will see differences in data that doesn't make sense. And is that provider a phone call or an email away to work with you to 1, see is the data correct, 2, does it need to be fixed, and then 3, to fix it? And I can attest StreetLight is one of the best platforms I've ever worked with. They're not just going to hand you the data, they're going to stay through the project and make sure you get the results you need. So finally, to the case study. And the project is on ADOT's facility, the Arizona Department of Transportation, along the Loop 101 from 75th Avenue to I-17 in Phoenix. Now, this is a 6-mile urban corridor, and pre-COVID time, the ADT was about 132,000. And using multiple data sources, we found out that generally volumes are down about 20% when we started the traffic analysis. And we're still ongoing with this project. We are getting through scoping phase right now, and then we'll be moving to final design. But we were able to figure out some of the preliminary traffic results to have this presentation. And the picture you can see on the top right of your screen, this is on the east end of the project looking west. And as you can tell, the east side of it is a major traffic interchange with the I-17 corridor, which, if you're not familiar with the Phoenix area, is the main corridor to get to northern Arizona from Phoenix and other southern parts of the state. And quite a bit of commercial traffic, quite a bit of volumes in general. And the simulation, some of the answers we needed was, how will the I-17 interact with the 101? And to give you perspective on the volume differences, the 101 going under I-17 compared to the ramps that merge and diverge onto the 101 is about a 50-50% split. So in the traffic world, now I'm worried about weaving, because you've got a lot of people in the right lanes trying to get to the left lanes and vice versa to get their entrance and exits they want. And the last thing I'd want to point out about the corridor is, as you can see in that same graphic, on the left side, there's a large commercial mall, and on the right side, there's a lot of businesses. So even though we know that the volumes generally were down 20%, those types of land uses are going to be affected more by COVID and the reduction, because at 9 a.m., not everyone's trying to get to their office building at the exact same time and everyone's making a right turn. So we needed origin destination data to help calibrate our model and be able to look at the trends, not of just now during the COVID situation, but also what would be normal, and hopefully will be normal again very soon. So the traffic challenge was that the base project was adding a general purpose lane in each direction, but with all the given information, we needed to look at entrance, exit ramps, how many lanes coming from I-17. We were looking at hard shoulder running, narrowing lanes or shoulders, and seeing if we can get the capacity improvements we needed. So in total, we had 10 different traffic models that were running both AM and PM, and our time frame was basically from starting the existing model to all 10 alternatives was about 4 weeks. So as a traffic modeler, that's a pretty quick turnaround when you're doing microsimulation, and it was all during COVID-19. So the question is, how do we calibrate mainline? And the last thing I want to point out on this slide is in the lower right, you'll see a Google that shows the traffic patterns. This was yesterday during the PM peak hour to kind of show you this would have been all 3/4 red last year during the same time, but you're seeing the impacts. So how do we do the modeling? We use the Vism software, which is, traffic modelers know, is very data intensive. And how do we calibrate that data? Well, the good news is this was an urban corridor, so ADOT has quite a few traffic recorders that are counting volumes, as well as there's a lot of speed data on mainline itself. So we could look at 2019 information from those systems and use that to calibrate our model. We also took field counts on the crossroads. Now, where StreetLight plays in huge is that OD component of what were the traffic patterns like in 2019. And instead of deploying Bluetooth Arid or those kind of devices, we were able to look historically at a bunch of data that were seasonal to when we're looking at for peak periods and calibrate that into the model and really look and be able to create realistic weaving scenarios throughout the corridor. And also we were able to get some adjustment factors for crossroads to kind of gut check on the increases of volumes from field data collection we needed to represent normal conditions that were not COVID. So in a nutshell, for the Vism model, the OD, this is what we use to input. You'll see from the next presentations, the StreetLight platform is way more beautiful than this, but this is our Excel version of the data. So we exported the StreetLight data and we're able to take this graphic and move it into our Vism model for all origin destination. And this, like logging into StreetLight into our Vism model, was 1 day, which is completely different than if trying to deploy Arid devices or Bluetooth for weeks on end. So this really helped us meet our schedule. And then to wrap things up, I just want to talk about the preliminary results. Once again, this is still ongoing. So please follow up with me if you have any more questions or want to see where this lands. But in general, the big takeaway, and that was a pun I didn't mean, the big takeaway for big data is that it helped us to calibrate the models and meet the fast track schedule and be able to calibrate it for the COVID situation and try to figure out what the normal would have been. And sample size comes up a lot with data. And to give perspective, the StreetLight OD data that we took from 2019 included over 7.3 million trips on this quarter alone that we were able to use. And the next bullet, Vism modelers will definitely know, but one of the main validation techniques we use for Vism model is when we put in where the volume should be along the corridor, and we compare that to once we run the model and it integrates and runs all the vehicles through the corridor, what are the outputs? And from volume input to output, we were within 10%, and most main lines, we were under 3% difference between the two. And then going back to the mainline speeds that we pulled from ADOT, we were within 15% of the speed data that we were able to get. And I would preface this with an asterisk that when we're doing Vism models and it's through heavily congested corridors where you got level service F skyrocketing, usually the Vism model, in my experience, is going to show a lower average speed than what data field collection is showing, which is the same case that has happened here. So to wrap things up, big data really helped us to inform the traffic analysis to make better decisions and better recommendations going into the future design for this project. So I think we're going to take a pause, and if there's any questions on my presentation, I think, Jim, you've got access to those. I'm sorry, I ran through that really quick, but we're tight on time.
No, you're good, Stephen. In fact, yeah, I think we've got about 3 minutes before we'll go to the next presenter. And you do have a question that came in. The question is, you mentioned that you used StreetLight's volume. If so, what was your experience with using those volumes?
That's a great question. And since ADOT had volumes from the mainline detectors, we did use those volumes for our existing conditions and calibrated them up to 2020. Where we did definitely use StreetLight volumes was comparing the crossroads to mainline. So, and Jim can probably go in a little more detail, but StreetLight offers volumes based upon the data that they have access to. And unfortunately, all the technologies, there's not data for every single car. So one of the features that I think is unique to StreetLight that offers a lot of value is you can actually plug in where you have volume data. So I can go into StreetLight, point at a mainline segment, and then put in ADOT's traffic recorder numbers in there, and then StreetLight will calibrate up or down, I guess, the area around it, so the crossroads or the main line. So Jim, I don't know if did I describe that right? Did you have anything else to add on the back end?
Sure. Actually, I think you got it perfectly accurate. I'll just mention that that's one option available within the application is like a calibration. This is a single factor calibration using the user provided counts. There is, in cases where no calibration data is available, there's also a kind of a StreetLight derived estimate of volume as well, based on some algorithms that we developed that Matt mentioned in his intro presentation to estimate where no local calibration data is available. There's another question, Stephen. Do you plan to use big data for the same calibration techniques post-COVID?
That is a very good question. And it kind of goes back to every project's very specific and the answers we're trying to get. And big data, you look at all the calibration that's been done and the documentation, it's becoming more and more of a viable and I'd say usable calibration technique that we've done on multiple projects. And looking at the Vism results that we did on this project, the speed's fairly accurate, the volume was accurate, the queuing spacing and just the congestion that we're seeing in the model does match with what was happening prior to COVID. So I do think there is a lot of value that big data has for microsimulation calibration.